All right, so the first problem you guys are having trouble with on the homework is if two lines are coplanar, which of the following must be true? Okay, so let's draw a big plane here. There's a plane. Okay, let's go through them. Which of the following must be true? The lines intersect. Okay, so there's a line on the plane and there's a line on the plane and they intersect right here. So that could happen, but it could also be the case that here's a line on the plane and here's a line on the plane, and they are what are called parallel lines. And parallel lines never intersect. So the lines intersect, well, maybe they're parallel, so no. The lines never intersect, well, maybe they're like this one, and they do intersect, so no, it can't. So those might be true, but this is which one must be true. So it's not those two, okay? So, oops, let's go through and get rid of those. Okay, so we said it's not F, it's not G. Okay, let's try this one. All points on the lines are coplanar. Okay, so here's a line and here's a line. They can be intersecting or it could be like this. They're not intersecting, but either way, we've got two lines, we'll say there and there. Okay, well, both of these lines are on this plane. That's what it says. These lines are coplanar. So this point and this point and this point and this point, all these points on this line are in the plane, as are all the points in this line. And again, the line goes on and on forever and ever in both directions, but all the points in this line are going to be in this plane because all the line is on the plane, and all the points in this line are going to be on the plane. So that's it. So it's going to be this one right here, and then finally, let's get rid of the lines here. Okay, and then finally, oops, so we said it's this one. And then finally, the lines share at least one point. Well, again, in this example, they do, but if the lines are parallel, then they don't. So it's not that one. So the only one that must be true in this case is H. All right, let's look at the next problem here. Don't save. Okay, here's the next problem. All right, using this diagram to the right, how many planes are contained in KL, the line KL, and the point G? So again, let's just draw a plane here again. So a plane, you need, as we said, we need 3 points. So if I have point, whatever, those 3 points, we'll call them point A, B, and C. Now I know that's a plane. Again, like three legs of a stool. Those 3 legs of a stool can only hit the floor in one way. That A, B, C, we know that's a plane. Okay, well now let's label them differently here. Let's say that this is K, this is point K over here, and this is point L over here, and they make a line. And that line they make is line KL. And that line KL for us is right here on the diagram, but whatever, there's some line KL, here's line KL, and then there's some point, we're going to call this point G. Here's a point G here, over here it's point G. Okay, but I have 3 points, K, L, and G, and that's 3 points, and it takes 3 points to make a plane. In fact, 3 unique points, at least 3 non-collinear points, make up a plane. Again, like 3 points on a stool. So how many planes contain KL and G? Well, there's only one. Only one plane contains KL and G. So that's the answer for that one. Okay, and the final homework problem you have is this one. It looks very similar, but let's see how you'll see how it's a little different here. Okay, here's my problem. Okay, so once again, I've got a plane. Draw my plane here. Okay, and now I have NM, so this line right here, and point M. So again, as we said, a plane needs 3 points. So whatever, 1, 2, 3. There's only one plane that has these three points in it. However, if I only have 2 points, then there's actually this. So these 2 points make a line here, and there actually are an infinite number of planes that go around that line. Again, you can imagine your head if you were holding up a pen or something that represents a line. How many ways could you put a piece of paper through that pen? And the answer is you could do it an infinite number of ways. There's an infinite number of ways that you could put a paper, or a piece of cardboard, whatever that touches a pen. It's only when you add that third point that there's only one. It's only when you add this third point over here that there's only one way to do that. There's only one plane. But if you have just a line, I don't know if I can draw it. This is gonna be tough. Let's see. If I have a line, right? I've got a plane that goes around this way, that goes around it. I've got a plane that goes around sort of this way, that goes around it. Again, I'm a terrible drawer, but whatever. I've got a plane this way, it goes around. There's a million different planes that again sort of cycle around that one line. Okay, so now what's this question asking us here? So it's asking us how many planes contain the line NM. So let's draw NM. Here's point N. Here's point M. So there's my line. Let's draw that line. Great. So there's point M and point M. Well, point M is on that line already. So how many planes contain N, M, and M? Well, that's just the same thing as saying NM. How many planes contain this line? And so the answer is going to be infinity. Infinity planes contain that line because, again, you need 3 points to have a distinct, unique plane. Only 2 will give you an infinite number. So this one, the answer would be infinite.